Hello everyone and welcome back to a new session for Computer Science 2. This session is for Chapter 15, Inheritance topic. Chapter 15 is both inheritance and polymorphism. This session is only talking about inheritance, and I will also assign you homework 4, sorry, and I will assign you project 2 as well. So, inheritance. Inheritance. What is inheritance? Inheritance allows a new class to be based on an existing class. That's the simplest definition. So the new class basically automatically inherits all the member variables and functions from the base class, except for constructors and destructors. Well, it's gonna have one destructor, so except for constructors and destructor. So basically, you can use the terms base derived or parent child. So base class, derived class, or parent class, child class. So you're gonna have a base class that has private section, public section. It has some variables, some methods or variables that are public. And then we're gonna inherit from the base and add stuff. So when we inherit from the base, we're gonna get everything in the base plus whatever we define in the derived class. So there is generalization and specialization. In a real world, many objects are specialized version of other more general objects. For example, the term insect. Insect. It describes this. It describes a general type of creature and has a lot of characteristics and functionalities. Insect is very general. And because a grasshopper, for example, and bumblebees are insects, so these two have all the characteristics that an insect has, plus special or specific characteristics that are special to grasshoppers or special to bumblebees. So insect is the generalization, and then grasshoppers, bumblebees are the specialization. In addition, they have special methods also, like jumping. Grasshoppers jump. Um, so a generalization would be, for example, color, age, maybe. All insects has age. All insects has color. So grasshoppers will have colors, age. In addition to those, it has its, for example, jumping ability. Not all insects jump. Jumping ability is specific to grasshopper ability. And the bumblebee, on the other hand, it stinks. So a bumblebee has a color, has an age, plus stink or stinger. So these two are specialized versions of an insect. That's the idea behind inheritance. So in inheritance, we allow new class to be based on an existing class. This way, we reuse the code instead of writing everything from scratch. And this has a nice diagram on page 908, which is figure 15-1, that shows in details how this example is illustrated. You need to know that there is an is-a relationship. The is-a relationship means a bumblebee is a insect. So the derived classes is a base class. A bumblebee is an insect. This will be demonstrated later. You're gonna see that if a method, for example, or a function expecting a bumblebee data type, you can send it an insect data type because of this is a relationship. Because a bumblebee is a insect, you can send an insect instead. And you're going to see it later in polymorphism, where you're going to have, for example, a container of insects, but each data type is insect. So vector, for example, insect. Vector of insect, but every insect is a special insect. It can be a grasshopper, it can be a bumblebee, although the data type is an insect. But every item might have a specialization in it. But this is for later. So when one object is a specialized version of another object, then there is this is a relationship. For example, another example, a car is a vehicle. A rectangle is a shape. For example, football player. So football player is a general specialized players are a or an in this case athletes or athlete. So anytime a derived or anytime one object is a special version of another object, then there is this is a relationship. So let me go to Visual Studio and show you an example. Let's say I'm gonna do the rectangle example. So I have a shape, class, right? Class, shape, and this shape has a private section and a public section. In the private section, every shape has color, for example, color code. Oh, actually, there is a nice example in the book. Let's actually do that nice example. So the example is graded activity. So there is a general class called a graded activity. Now graded activity has a private section and has a public section, just like we saw in chapter 14. So in this case, every graded activity has a score, and every class has a constructor. So I'm going to say graded activity constructor. This is the default one. So I'm going to say score equals 0. And then I'm going to type an overloaded one, graded activity that receives a double A score, and then it sets M score equals to A score. Let's actually do this way, just so I can save oops. It's not gonna allow me. Fine. Let's do it on one line because I don't want to take all the screen. If you remember, this is called inline. I'm defining the functions inline, not outside the class, inside the class. So I have an overloaded constructor. Then I have a mutator and accessor. So I have a set and get functions. So set score. This takes a double A score, and then it says M score equals A score. And I have a double get score, doesn't take anything, and it returns M score, basically. Then I have a function called get letter grade, and it's constant because it's get. So let's put const next to any function that is getting. So now this go inside a header file, but I'm not gonna move it to a header file. This is called the class interface. Now, since I defined some functions, it can't be called interface anymore because I have some definitions in it. But usually, if you have only the prototypes of the functions, then it's called, this is the prototype, for example. Then it's gonna be called uh, interface and will go inside a header file. Then inside your source file, you're gonna add a new file, call it graded activity, and you're gonna put the function definitions in those um, um, file. So everything is in line, except I'm gonna actually let's do it. So I'm gonna add a new item. I'm gonna say it's a header file, and I'm gonna call it graded activity. Graded activity. Add. So now I have graded activity. I'm gonna come to my console. I'm gonna say, give me this one and dump it here. Here is my class. And since I'm using primitive data types, I don't need to include anything. Then I'm gonna go here and say, add a new item. And this time I'm gonna add a CPP file. And I'm gonna say graded activity dot CPP add. So here is graded activity dot CPP. Then, yes, I did actually define these here, but I didn't define this one. So I'm gonna go ahead and define it in the CPP file. So I'm gonna say include, so that the compiler knows what I'm talking about. Include this, and then I'm gonna say there is a character for the graded activity class called get letter grade, and it is a const, and this one I'm gonna provide now the definition for this method. I'm gonna say I would like to prepare a character, a letter grade. This would be the one that I'm gonna return, and then if M score is greater than 89, then L letter grade, L letter grade. Why it's not getting it? L letter grade. Oh, because I'm outside the scope. L letter grade is A. Else, if M score greater than, in this case, 79, L letter grade equals B, else if score greater than 69, then L letter grade equals C, else if score greater than 59, L letter grade equals D, else L letter grade equals F. And then return L letter grade. So as simple as that. So now I can go and exercise this class. I can come to my main and I can say include this class. And now I can use this class. I can say, let's read from the user. So let's prepare test score. And then let's prepare the class graded activity L test. So double test score, and then I'm gonna say C out, enter your numeric test score. Or without, and I'm gonna read into L test score, and then I'm gonna call my object L test and set score, giving it my test score. So now I can exercise this class just to make sure that it is working. So the grade for the test is, I'm gonna call my test, and then I'm gonna say get letter and L. So now if I execute, and I'm gonna give it 95, it should be A. So here it is, A. If I give it, for example, 89, then it's B. If I give it 69, then it is D. So this is so far so good. We didn't start inheritance yet, but now I'm about to inherit from this class. Graded activity is very general. A special or a specific type of a graded activity is a final exam. A final exam is a graded activity, but has some um, specialization in it. For example, we're gonna say number of questions. Uh, uh, Other tests have um, less number, or um, let's say, yeah, number of questions. Because a graded activity may not have number of questions, may not have questions at all. So I'm gonna go ahead. I'm gonna say add a new item, this time header, and I'm gonna call it final exam. And in here, I'm gonna say, since I'm inheriting from graded activity, then I have to include it. Graded activity. Then I'm gonna create my class. I'm gonna say class final exam, and then colon. Colon public graded activity. Now I inherited it from graded activity. By doing the colon public graded activity, and we're gonna go over public later in this session. But for now, colon public grade activity, that means final exam is inheriting from graded activity. So a final exam has a private section and has a public section. In the private section, we're gonna say we have num questions. We have a double points each, and then I'm gonna say int num missed or missed num. Then in the public section, if eventually I'm gonna have a constructor. I'm gonna say mnum missed equals 0, mnum questions equals 0, and points each equals 0. Then we're gonna have an overloaded function, an overloaded constructor. This takes int a questions, and it takes int a missed, and then we're gonna set um, set a num questions num of questions equal a questions, and then missed equal a missed, and then for the one more points each, I'm gonna say it's whatever 100 over, right? 100 points. So I'm gonna say m points each would be equal to 100 over whatever number of questions we have. Num of questions. Because it's over 100. Then I'm gonna have mutator and accessor. So I'm gonna say void set int, and this is for set values, int a questions and int a missed. Then I'm gonna have a double get num questions const return num questions, get points each. Of course, it's a const as well. And then it returns points each. As a matter of fact, since I have this set values, I can move these and I can say, let's take this to set values, and then I'm gonna say set values a questions a missed, just so I don't have duplicate. So this is my header file. Now I'm gonna add the CPP file. Actually, let's get one more int get num missed const, and this returns return num missed. So now add new item. This time it's a CPP file, and I'm gonna call it final exam. Add. In my final exam, I'm gonna include final exam, and then I'm gonna say there is a void final exam class called set values, and it takes what? It takes an integer questions int a missed, and then I can have this. So questions go to questions, missed go to missed, and then points each go to points each. And then what we can do is now that this has been set and final exam is inherited from graded activity, we need to set the score in the base class. So I'm gonna say double L numeric score, and this numeric score L numeric equals whatever the full grade minus missed, A missed or unmissed. In this case, they are the same points each, right? It's whatever we are subtracting, whatever they missed. So num missed. Now that I know what is their numeric score, so I'm gonna say set score. Now notice set score is from the parent class. We didn't define it here, but we inherited it from the parent class. So it's available in the derived class. Set score, if I say go to definition, notice it jumps to graded activity. So final exam has everything from the parent plus specific members for itself. And this is the example. Set score is from the parent, but final exam has it. And not just set score. Your final exam has everything in graded activity. So now, with that being said, we can exercise our class back to main. I can say, let's take all these out. Well, let's prepare int l questions, int l missed, and then I'm gonna say how many questions are on the final exam. Cn l questions. Then I'm gonna say cout how many questions did the student miss? And then Cn into L missed. Then I'm gonna say, okay, final exam. I don't have it because I did not include it. So final exam. So now L, no, not L, final exam, L final exam. And I can, as a matter of fact, notice it suggests the overloaded constructor for me, which is this version. So I have one version. This is a copy constructor, another version, and then this version, and then the default one. So I'm using this version, which take questions first, and then it takes L missed second. Now that I set these values, I'm gonna just display stuff. So now I'm gonna say, L final exam, or let's give it each question counts how many points. So L final exam dot get points each. And then I'm gonna say the exam score is L final exam dot get, notice, get set score, those are from the graded activity. Even this one, so it's a final exam, but I have everything in final exam and from the parent. In this case, I'm gonna say get score, and finally I'm gonna get the letter. So cout the exam grade is L final exam dot get letter grade and L. So let's run it. I'm gonna say how many questions we have 20. And how many questions did the student miss? I'm gonna say they missed 3. So each question is 5 points. The exam score is 85 because the 3 questions were missed. So the letter is B. Final exam is derived from graded activity. So it has stuff special or specific to a final exam, and it has stuff from the parent. Now, I want to speak about protected. As you noticed, or as you know by now, when you go to any class, there is a private section and then there is a public section. Now, there is a protected section. So if I go here, I can say protected. Protected members of a base class or a parent class are similar to a private members. They are not public. They are similar to a private members, but they can be accessed by the children classes or by the derived classes. So the base class access specification determines how private, public, and protected base classes are accessed. So everything I write in here are not public. So whoever creates a graded activity does not have access to a protected section. However, any children of that class will have access to those protected sections. For example, int m test, like testing. Notice if I come to main and I create a graded activity and I call it L activity, and then L activity and I open the encapsulation, notice I do not see mtest. Mtest is not public. However, if I come to final exam and inside any function in final exams, here, for example, just like I was able to access set score from the parent, notice that I have access to mtest. Because mtest is protected, so anything outside the base class does not have access to it. But the children, like here, final exam is a child of that class. Children have access to it, and I can set it, for example. So this, if I go to definition, notice it's in the protected. So protected sections are not private, are not public, are a section where only children or classes derived from this class have access to. Okay, that's basically protected. Now, I need you to pay very good attention. These are called access specifiers: private, protected, public. Access specifiers within the class. If I go to final exam, you're going to see another word, public, here. This public is different than this public, and I need you not to confuse them. These are access specifiers within the class. This is the inheritance type. There is a private inheritance, there is a protected inheritance, and there is a public inheritance. And those are one thing, and access specifiers are a different thing. Let's speak about this, the difference. So if I go here, I'm gonna draw the differences. So again, access specifiers are one thing, and inheritance types are another thing. So I'm gonna say we have base class members, right? And I have, I'm gonna call it how those members appear in derived classes. So I have members in the base class, and then if I derive, they will appear in the derived class, right? Just like here. If I go to CPP, This appeared in the derived class. This appeared in the derived class. So there are three different, eventually, there are three different inheritance type. We have a private inheritance. We have protected inheritance. And we have public inheritance. And again, these are different than access specifiers. So I'm gonna draw an arrow, and an arrow. So in the base class, I have access specifiers. I have a private section. I have a protected section. And I have a public section. Right? You agree? Every class has a private access specifier, has a protected access specifier, and has a public access specifier. Copy, paste, move it here. Actually, let's move it close. 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 And then we can take these out. So, in a private inheritance, how would a private member from the base class appear in the derived class? That's how you want to think about it. You know, from chapter 14, that no one has access to a private section of a class. No one, even children. So here, I'm gonna say no access for the private. So 1, 2, 3. 1, 2, 3. 1, 2, 3. So 1, even whether it's private or protected or public, the private section of a class, in this case the base class, is 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 private to this class, so no one has access to it, even children. So even children do not have access to private sections. So here I'm gonna say 1, no access, and then a protected member, if there is a member declared as a protected in the base class, in a private inheritance, this protected becomes a private in the derived class. Meaning the derived class will get that protection or protected member and will be set as a private in its own class. In its own scope, it will be declared as a private. That means anything outside the derived class does not have access to it because it will be set to a private. For example, if I have, in this case, test declared under protected in the base class, and then I derived final exam. If I derive as a private, then test becomes a private. Test becomes a private in the derived class, meaning if I create a final, did I create? Actually, we did create. Notice here. So here, if I say final dot, if I have it as private, then I won't have access to that protected member variable. So back to here, the fact that it's private, everything becomes private. Private. But for the private section, no one has access to private section. So private, no access. Protected becomes private. Public becomes private. In a protected fashion, if I inherit in a protected way, then, as I mentioned, no access to private section. And then this becomes, or stays in this case, protected. And this becomes protected. So basically, the derived class telling the base class, give me what I have access to and set them as a private, as a protected, sorry. So in a private type, the derived will tell the base class, give me what I have access to and set them as private. In a protected type, the derived class will say, give me what I have access to and I will set them to protected. And in a public type, one, no access. There's no access to a private section. And then this stays protected because you cannot expose. You cannot get a protected member and tell everybody to have access to it. So protected stays protected, and then public is actually public. So these are the differences in between public, protected, and private inheritance type. So what you see in the middle is the inheritance type, and these are access specifiers. This is where variables are get declared under these sections. Derived classes or any other classes do not have access to a private section of class, except friends, for example. A friend class can have access to a private section of another class if they are declared friends. Protected becomes private, public becomes private, private no access, protected becomes protected, public becomes protected, and in public, protected stays protected, public stays public. For example, in the one we have, the fact that mtest is declared under protected, then it becomes protected in the derived class. So if I come in main and I try to access mtest, I don't have access to it because it is set to be protected. And protected means it's not public. Protected means it's only available for children of this class. So children of final exam, in case I have children of this class, will have access to mtest. Notice, for example, if I change, let's say, what do we have? We have, okay, notice, for example, um, in here, this one was declared as public. Declared as public, and then did I use it here? For example, get score. Okay, get score, I'm using it from outside final exam. I'm using it from main. Main is outside. It's main is an outsider, right? Main is an outsider, and I'm using get score. Get score is available for me because the inheritance is public. Now, if I change this inheritance to be private, then notice I no longer have access to this. Why? Because if I look back to this, in a private inheritance, whatever was created public, which is the case, get score was created as public, right? Here it is. Well, not here, public. Get score, here it is. So it was declared as public. Now that I changed the inheritance type to be private, then everything that is declared as public becomes a private in the derived class. So here, final exam has access to it because it's inside the class. Set value is inside final exam, and set score is set to be private in this class. So set values have access to set score because they are in the same class. They are members of the same class. But set score is set to be private. So an outsider like main does not have access to it. It's gonna tell you, look, function blah 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 is unaccessible, is inaccessible. It's inaccessible because it's set to be private inside final exam, and no one has access to private section. So I'm gonna put it back to public, and now I have access to it. Next is passing values or calling the constructors of the base class from the derived class. So for example, here, final exam is inherited from graded activity. So final exam constructor should construct graded activity as well, especially here. So what is the way of passing arguments to the base class constructor? So let's add a constructor that actually takes or let's make it simpler. I'm gonna come here, I'm gonna remove these, right? And then I'm gonna make it simple. I'm gonna say I have a class called my base, right? And then I'm gonna say this has a public section, and this has a my base constructor, and I'm gonna say cout hello from base. Then I'm gonna have before the hello from base, let's have a private int base value. And this has a default constructor. I'm gonna say base value equals 0. And it has an overloaded one that takes an int a base value. And I'm gonna say this is equal to this. Then I have a class, my derived. I'm gonna say it is inherited from my base. Open parenthesis, private. I'm gonna say int um, derived value, public. It's gonna have constructors, so it's gonna have this, this, and this takes a derived, and this is the default, so I'm gonna say this is this. Now look at this. This needs to receive two. It needs to receive derived, and it needs to receive base. A derived, a base, right? If I create a class that is derived of other classes, I'm gonna have to pass the data for all the member variables, whether they are in the derived class or in the base class. Remember the diagram here? Insect, oops, insect. If I create a grasshopper and I wanna set some values in the constructor, I need to pass the jumping ability, the age, and the color. So from the constructor of the grasshopper, I need to set color and age. And how do I do that? I do it by basically, let's do this and then derived value. And the way you do it is you put semicolon or actually colon, and then you call the base class. So you say my base and you open parentheses. Now you are at the constructor level. Notice this is the default one. This is a copy constructor, and then this one is the one we wrote. So now I'm gonna give it a base value. So notice I'm gonna put a breakpoint here, and I'm gonna put breakpoint here. And I will create a my derived class, my derived instance. I'm gonna run with F11, F10. It didn't stop here, so let's put it again. Strange why it's not allowing me to stop here. I'm gonna type, oh, because I'm still F11. So now our default constructor. No, we don't want default constructor. We want we're gonna give 10 and then 1. So 1 for the base and 10 for derived. F10. So notice my derived, I'm gonna hit F11. So now I am in the constructor. Notice 10, or not yet. Now 10, 1. If I hit F11, it will jump to the constructor of the base class. And then it will finish the constructor of the derived class. So now derived has been set and base has been set 1, 10. So this is the piece of the puzzle. This is how you pass, whether it's 1 or 10 values. In the constructor of the derived, you put the colon and then the name of the base class, and then you start passing the values in the parentheses. Another thing I need you to know is, let's do it here. See out hello from derived, right? This is hello from derived. And then I have a hello from base. And I'm gonna add these structures, my base, and I'm gonna say by from base, by from derived. Now, if I create my base, L my base, then you know what happens. When this gets executed, the constructor will be called. So it's going to say hello from base. And then when the scope finishes, so when we reach the end of the scope, the destructor will be called, and then we're going to see goodbye from base. Now, let's verify. So bye from base, but it didn't say hello from base because it wasn't in the default constructor. So this is now in the default constructor, and this is now in the default constructor. So now, hello from base, bye from base, simple. Now, what happens if I create a my derived object? What I need you to know is, as a student, I always remembered it as building blocks. So in order to build, right, when you have building blocks, if you want to build like a building or a tower, then you put the first piece eventually, then the second piece, the third piece, the fourth piece, etc. So, so since this block depends on this block or based on this block, then this block should go first. Then this block should go second. This block should go third, fourth, because 2 is based on 1, 3 is based on 2. So so you always want to remember that whatever we are based on should go first. In this case, now if I run with F10 and I go inside my derived class, notice it's gonna say hello from base. So because derived was based on this class, the constructor of this class got called first, and then this will be called second. So now hello from base, hello from derived. And then if you wanna undo this, if I come and remove 2, it's gonna collapse. So you undo it the way you did it in a reverse order, meaning you put 1, 2, 3, 4. So to destruct it, you destruct 4, then 3, then 2, then 1. So notice when I hit return 0, it's gonna say buy from derived and then buy from base. So the derived gets destructed first. So this got destructed first and then the base, the derived and then the base. So I need you to pay very good attention to the flow, which one gets called first and which one gets called second, whether it's a constructor or a destructor. You need to know these. Now notice if I have 2, for example, my base in this case, right? So this will call the base first and the constructor, the base constructor first, and then the derived constructor second. then this will call the base constructor. So here it is. Hello from base, these two for the first object, and this one is for the second object. Now when I reach the end, I'm gonna put a breakpoint in the destructors. So now main is top down, right? So this was created first, and this was created second. So when we reach the end, this gets destructed first, and then this gets destructed second, bottom up. And this is inherited from my base. So the derived gets destructed first, and then the base independent from this fact. Now notice the destructor of this object will get called first, and here it is. Now that this one got destructed, this one will get destructed. And this one will destruct derived first, right? It's gonna destruct derived first, or here, derived first, and then base. So whatever it's based on, this gets destructed first, and then this gets destructed first. So now I'm gonna get hit in, come on, go, in my derived. So this call is coming from destructing this object. The derived destructor will get called first, and then the base of it will get destructed second. So now it destructed both objects and done. So you know how to pass arguments, and you know how the flow works. Then you need to know how to redefine base class functions. So redefining base class functions basically is having a member function from the base class that is redefined in the derived class. So it has the same name like we saw in here. This set score is coming from the parent. It's coming from graded activity. It is in final exam, but it's coming from graded activity. I can have a function in final exam called set score. So they're gonna have the same name, but if the child calls set score, it will execute its own version of set score. And if the parent or other children from that parent call set score, then they're gonna execute the version from the parent. So for example, let's come here. Let's move these to protected now that we have inheritance. We're gonna get rid of private. I'm gonna say this has a score. This one is just for testing. And here I'm gonna say we had that letter. So char letter grade. And then I'm gonna say a utility function called m or determine grade. And in the public section, we have this, and I'm gonna have it as is. And then we have the set score. Here it is. I'm gonna say, now that we set score, determine grade. Right? Anytime we set score, we want to determine the grade. So we can set this variable. Also here, get score stays as is, and then get letter stays as is. So determine grade. So let's go to get letter. And here I'm gonna say, give me these and return m letter grade. So now this is a getter, and I have a determine grade, and this determine grade will have this, and instead of return, I'm gonna say m letter grade equals l letter grade, semicolon. declaration is incompatible or void. It's a void function. And it's incompatible with void determine grade. Yeah, it is. Determine grade. Huh. Oh, what did I do? Strange. Oh, const. All right, here it is. So this will set letter grade. This will return letter grade. Here, what is this? Variable grade initialized. So I'm gonna say this is equals empty character. Graded activity, da da da. So this is ready. And then this is ready. So I'm gonna add new class. And this time I'm gonna call it curved activity. So curved activity header file, I'm gonna say class curved activity, and it inherits from public graded activity, and it didn't know about it because I didn't include. So include graded activity. So now it knows about it. I'm gonna say protected section. In the protected section, we have raw score, right? Which is score. And I have a percentage because in a curved activity, there is a percentage. Percentage. So this is a specific to a curved activity. And then in the public section, we have, of course, a default constructor. And this constructor will call graded activity constructor. And then I'm going to say raw equals 0 and percentage equals 0. And I have setters and getters. So I'm going to say void set score. Notice set score, we had it. We had set score from the parent, but in the child, I'm going to redefine it. I'm redefining the function because set score in a curved activity is not the same as setting score in a graded activity because there is a percentage. I need to recompute some stuff. So I'm going to say set score. This score will eventually receive a score. And then when I receive a score, I'm going to say the raw score is whatever I receive, right? And then I'm going to say, I'm going to call the parent and set score based on the percentage. And the way you do it is to differentiate between set score in this function and the one in the parent. You call the parent, so grade activity, colon, colon. So now you have it. Here it is, set score. Set score. Okay, set score. Test is gone. So set score. Now I'm gonna say it is whatever they gave us by the percentage. So set score, I redefined it. I made it different in the child. So there is a set score in the parent, but I redefined it in the child based on my approach or my design. Then we're gonna say we have getters. Actually, let's set percentage, and this takes a percentage. I'm gonna say percentage equals a percentage, and then get Get what? We're gonna get percentage for now. Const return and percentage. And then I'm gonna say get row score. Const return row score. Here it is. So now if I want to exercise it, I go to main. I no longer need these, so I'm gonna get rid of them. In main, I'm gonna say let's read some stuff. So L numeric score, and then the percentage. Then I'm gonna create an instance from the curved activity. Let's include it. Curved activity. So now curved activity L test, for example. And then I'm gonna read from the user. So I'm gonna say enter the student's row score. CN L numeric score. And then see out from enter the percentage or the curve percentage. CN L percentage. And then I'm gonna say let's set some stuff. So let's send these set percentage L percentage, and then L test set score. So you see, set score is the one in curved activity, although it's in the parent too. So I was able to redefine set score. So set score L numeric score. Now, if I uh, grab or get some stuff, I can say see out the row score is L test dot get row score and L, and then I can say the curved score is get score. Here it is. And then I can say the curved grade or the curved letter. The curved letter grade is get letter grade. So set score is the one that we defined. So let me run the program. I'm gonna say the row score is 87. The percentage is, for example, 1.06. So now the row score is this. The curved score is 87 multiplied by 106. And then the letter is A because 92. So here, when we read the percentage, we set the score, and we set the score not through the parent, but through the child. This set score is in the child class. So we redefined set score so that we do whatever the instance or the design of this child must do. The last topic in this section is basically telling you that a derived class can also be a base class. So if I go to the whiteboard, you can have basically this way. You can have a class 1 and then inherit from it class 2 and then inherit class 3. So this derived class can also be a parent class. For example, uh, living creature, right? And then insect, and then bumblebee, right? So an insect is both derived and base, or both parent and child. You can have this way, you can have uh, two different derived for the same parent. So C1, C2, C2 prime. For example, I can have a vehicle or car specific. I can have a Ford car. I can have a GMC car. And another example is having two parents. A class can have two parents. So I can have C1, C2, and then C3. C3 will grab both C1 and C2. What's a good example from this one? A good example is, for example, when you study for your PhD, you are an employee and a student at the same time. So you're gonna have student, class, and employee class, and then this C3 is both student plus employee. So it has all the attributes or characteristics of a student. It has a student ID, has courses, has grades, and also all the characteristics of an employee. He has a salary, he has like hours worked, goals, raise, bonus, etc. So this is called class hierarchies. You have class hierarchies. So with that being said, this is it for inheritance. Now, next session, I'm gonna try to do an exercise in front of you since this is an online class. Usually in class, we do a lab where I put lab on the board, like write a class that does this and that, and then the students start working on it, and I start like helping, walking around. So what I'm gonna do is I'm gonna share my screen, show the exercise and then do it in front of you. I'll do it maybe tonight or tomorrow. So this is it, and let me know if you have any questions.